Hello, in this video we will discuss one question based on the concept of position and displacement vectors. I hope that might help you understanding why we need them, their use, and what we can figure out in terms of motion of a particle, so on and so forth. So let us describe the question now. So I don't need this, let me get rid of that. So the question involves a skating ring. Let me draw a circle like so. And on this circular skating ring, you have two people, person A and person B. The first person, or person A, decides to go from point P1 to point P2, that's point P2, in a straight line, like so. So this is the motion of the first body A. And the second person goes in a spherical manner, in a circular manner, to point P2. So person A and person B both are traveling towards P2. So the motion is from P1 to P2. The first route that the person A takes is across the diameter. So if we assume that this diameter, or in this case the radius of the circular ring is r, then the person moves along the diameter and ends up at point P2. So this is along the diameter. Person B goes along the circumference from point P1 to point P2. Now we can figure out many things based on that, and the information that both of them start at point P1 and end up at P2 at the same point of time. That means both take time t to travel from P1 to P2. Alright, so that is the entire setup of the question, and let us try to figure out the average speed, the average velocities, the distances and the times, and also the displacements for the two motions. So let me get rid of this for the moment, and let's look at person A. So person A goes across the diameter. What do we know about the diameter? Well, the diameter, or the length P1 to P2 in a straight line would be twice the radius, and hence would be 2 times r. So that's the distance that the person is traveling. So this is the distance. Let me write it down. So this is the distance traveled by person A. For person B, if you look at person B's movement, well, person B goes from P1 to P2 across a circular path, so something like that. And the distance that exists between P1 and P2 across the circumference of the ring, of the ice ring, is well, half of the circumference. So the total circumference of the circle, so that would be 2 pi r by 2, and that gives you pi r. So that's the distance, again, that's the distance traveled by B. So if you look at the problem, it's obvious that person A and person B are traveling do different distances. The first person travels a rather short distance of 2r, and the second person travels a distance of pi r. And pi r is greater than 2r because pi is greater than 2. Pi is somewhere around 3.14, and that's obviously greater than 2. No matter what the radius, person B will definitely be traveling a greater distance. Now, that was the discussion about the distances. What about the displacements? So if you look at the displacements, well, for displacement, we know that if we want to talk about the displacements, we need to first talk about the position vectors to be really thorough with what we're doing. So to define position vectors for point P1 and point P2, the start and end of the journeys of both the persons, we need to define an origin. So let us define an origin, an arbitrary origin, say this be our origin. The first vector will therefore be from the origin to point P1. So this is O. The first vector would be OP1. This is my initial position vector. my second vector, or the terminal position vector, would be from point O to P2. This is P2. That would be something like this. And that would be OP2 vector. That would be the final position vector. So there you have it, the initial and the final position vectors across the motion that we want to consider for both the persons. Now, what do we know about the displacement vector? Well, the displacement vector, let me change my color for that. Yeah, pink works fine. The displacement vector, we all know, must be final position vector minus initial position vector. So final position vector minus initial position vector is OP2 minus OP1. So we want to go, subtract OP1 vector from OP2. And if you think about it, that would be the vector starting from P1, ending or terminating at P2. That would be your displacement vector. So displacement vector would therefore be D. And let's define our directions, I direction in the X and J direction in the Y. Therefore, all that's left to do is to give this some magnitude and the direction. So direction is across the Y direction. That would be therefore J cap. What about the magnitude? Well, we know since both the bodies are ultimately at landing at P2 and starting at P1, therefore the straight line connecting both of them, which is the vector, the d vector, the displacement vector, the length of that is 2 times r. So that's 2r, or twice the radius, or the diameter. So this forms our displacement vector. Now that we have that sorted, what we can do is we can use this displacement vector to define quantities like average speed, average velocities. Now if you notice, for both the bodies, A and B, since both start and end at P1 and P2 respectively, both have the same displacement vectors. There's nothing different about the motions of both of them if you talk about in vectors. However, in actuality, there is a difference, but in terms of vectors, there isn't really. So that means they both are going to have the same average velocities. And how do we know the average velocities? Well, in order to do that, let me get rid of this for the moment. Well, average velocity. Now this is the average velocity for A and for B, would be the displacement vector divided by the time taken. So if we have the time to be, say, t, then the displacement vector would be 2r by t j cap. So the average velocity would be 2r by t j cap. So that means this would be a velocity in the j direction. So the velocity, the average velocity, would still be in this direction, in the y direction. May differ, and should differ in fact, from the length of the displacement vector, because we are dividing that by a constant, a scalar of time t, but would still be pointing in the same direction, because we know that if you have a vector a and you modify it by multiplying it by lambda a, where lambda is a constant, the direction is still the same as long as lambda is greater than 0. If lambda is less than 0, then even then the direction is directly opposite, but still along the same line. So with that in mind, we know that v, or the average velocity vector for this part of the motion, will therefore be, well, pointing in the y direction. So that's your average velocity. Now, in summary, what we ended up doing in this question was looking at the physics of both the motions. And the reason we started with both the motions, in which person A moves along the diameter and the person B moves along the circumference, was because I wanted you to think about the fact that even if two persons go along different paths, they go along different trajectories, they end up at the same position. Even if they have different paths, they still have the same displacement vectors. So for all I know, if you would have taken a, let's take another random path from point P1, going like this all the way, okay, that went outside, going like this all the way to point P2, maybe a third person could have done that. And even if that were the case, the distance traveled by the third person, person C, would definitely be different from 2r or even pi r, but they would still have the same displacement vector of d, because the displacement vector depends only on the initial and the final positions of the motion. So if we consider only this part of the motion of the person, the displacement vector would still be the same. Not only that, if we know that the person covers this distance defined with the red line in the same amount of time as the other two, A and B, then t would be the same, and therefore average velocity would therefore be the same as 2r by t j cap. So that is a slightly weird aspect of vectorial analysis, or basically vectors, but that helps. Later on, we will use this concept to define very, very important concepts in physics and really facilitate their understanding as well. So I hope this video made sense. I hope you understand how imperative it is to use vectors and how easily they can represent situations, but also that can be misleading at times when you have different motions to consider, and many times different motions have the same vectorial parameters, like average velocity and displacement, even when the distances might be different. So hope this helps, and all the very best, and have fun.